Oh, it's recording. Look at you, Spencer. Okay, thank you, Spencer. So arc length of a circle. So this is a lot of geometry until we get to the radian part, okay? So technically, we learn that with arc length, it's got to be the same as the angle if it's in terms of radians. So if we want to do arc length for radians, it's just going to be S is the symbol for arc length. You go simply R theta. But that's if theta is in terms of radians. So today's objective is arc length and area of sectors. Okay? Alright, so S equals R theta, because in this picture, what the cool part about radians is if the angle's in radians, it equals the arc length. Well, but every circle's a little bit bigger, so that's why it's got to be the radius. So you multiply by the radius times the angle. That's it. That's the beauty of radians. However, if it's in terms of degrees, then you have to have your conversion, so it could be S is equal to, you ready? Theta over 360, because it's a portion of the full circle, right? Times your circumference formula, which is 2 pi r. All right, well, if I look at these two formulas, I'd much rather use this one, S equals r theta, right? And that's the beauty of radians, is that with the radians, it's a simple formula. If it's not, here's your conversion right here from degrees to radius. And I could simplify this, the 2 and the 180, 2 and the 360, I can say S is equal to theta over 180 times pi r. Okay, so either one of these forms will work. It just depends on whether theta is given to you in degrees or radians, okay? So, is it in degrees or is it in radians, okay? Now, sector. Sector is like the area of the pie, right? So if I'm hungry and I want to eat a piece of pie, that's the area of the sector, okay? So the area of the sector, if it's in radians, is just going to be, and they like the symbol K for it. K is 1/2 r squared theta, because theta in radians is related to the arc length. Super easy formula, right? Because you have a definite connection between the two. If it's in degrees, then the form is a little bit more cumbersome because, you know, it's a degree, right? So we could have then instead my K is equal to my theta over 360, because it's what portion of the circle, times the area of the circle, times pi r squared, okay? So if you're given degrees, you're just going to take what portion of my circle in terms of degrees times pi r squared, right? The nice thing about radians, it's already got it in there because we know the arc length is equal to it. Now there's one more formula, and that is sometimes you can see this one, K, which is the area, is equal to 1/2 r times S. If you know the arc length and the radius, because they're all related, all three, the arc length and the radius and the angle are all related, you can also find the area of the sector, okay? Now, let's go ahead and use this, okay? So example 1. Find the arc length and the area of the sector, okay? So, here's how it works. Take a look at it. I've got degrees. So I want to use these formulas, okay? I've got degrees, it's 110 degrees, so I want to use these formulas, okay? So I want first arc length. So arc length is S equals, okay, and I want to use the arc length formula, which is this one. So I just plug the numbers into this formula. So I'm going to have 110 degrees over 180 times pi times the radius, which is 6. Okay, and I'm just going to use my calculator to get an answer of what it is. Okay, so let's see. And 110 divided by 180 times pi pi times 6, and I get an answer of about 11.52 maybe, okay? 11.52 centimeters, okay? Pretty easy. You just have to find the formula that works. Area of the sector. These are my sectors, right? My area of my sector. And this is given in terms of degrees, so I want to use this formula, okay? I want the area of the sector. It's in degrees. I'm going to use this formula here, so I'm just going to go K, which is the symbol for area of the sector, is equal to my angle is 110 over 360 pi times 6 squared, okay? And I'm just going to use my calculator, 110 divided by 360 times pi times 6 squared. And you get an answer of about 34.56 centimeters squared because it's an area, okay? Centimeters squared because it's an area, okay? How am I doing? This isn't so bad, right? You just have to look for the formula that works for you, okay? Okay, example 2. Sector of a circle has an arc length, so S is 6, and an area of 75. Find the radius and the central angle. Okay, now let's find the angle in terms of radians, okay? Because it's easier. Plus, I want to get us more and more closer to doing radians, okay? So, let's first of all talk about the sector, okay? So, if I've got S is 6 and K is 75, and I want to find the radius, which of these formulas do you think would work for us? Okay, we have S and we have K. S and K. Which of these 5 formulas would work for us? Okay. How about that one right there? Is that a good one? I know my S. There's 6. K is 75. I can find the radius, right? So I'm going to use my K equals 1/2 RS, right? I know K is 75. My radius is what I want to find, and my arc length is 6, okay? All right, so that's half of 6 is 3. Divide by 3, R is 25. Okay, that's a pretty long radius. So this thing would actually look something like this. Super long and super thin. Not that you need to know that, but this would be 6 and that's 25. Okay, now let's find the central angle. So if I need the angle, let's see, I have R, and I need the angle. So I could use this formula, or I could use the formula. It doesn't matter. I could use either one. Which one do you want to use? This top formula or the second formula? First or second? Doesn't matter. Good, Nina? How about the first one? It seems easier, right? You guys agree? Yes, use the first one. I mean, both will work. Does that make sense? But let's use this one. It's easier, okay? So let's use our S equals R theta. I know S is my arc length. My R I know is 25 times theta. Divide. Now remember, that's an angle in terms of radians, 6/25. And I was pretty sure it was a small angle to start with just by the drawing, okay? That is an angle in terms of radians. Okay, ready to turn the page? I'll wait for you. All right, example 3. A sector of a circle has an area. So that's K. I'm going to write this down. I like to write what I know, okay? So now K is 25. I'm just going to write it. Sector of a circle has an area of 25. That's K. And a central angle, that's theta, of 1.5 radians, okay? Find the radius and the arc length. Okay, so very similar to what I just did, right? I want to find the radius, R equals, and S equals, okay? So K and theta, K and theta, K and theta. How about this one? K and theta, I've got K, I can find the radius, right? Does that make sense? Let's use this one. So let's write k equals, I'm going to write down my k equals my 1/2 r squared theta. That's the formula I want to use. If I put 25 in for the area and 1.5 in for the angle, I can find the radius, right? Okay, so I'm going to go. So what I do is I write down what I know, I write down what I want to find, and then I find the formula will do work. Okay, I'll say it again. I write down what I know, I write down what I want to find, and then I find the formula that will work for me. Okay, so k is 25, 1/2 r squared times 1.5, okay? Okay, half of 1.5, I think that's 0.75. Just going to multiply, so I get 25 equals r squared times 0.75. I just divided 2 into 1, or took half of 1.5. I'm going to divide. So what is 25 divided by 0.75? And I get an answer of about 33.3 equals r squared. Square root that, right? So the radius is about 5.77. R equals, I did the square root, right? Square root. R is about 5.77. Centimeters, right? Yeah, centimeters, okay. Now, I want to find the arc length. Well, shoot. I'm just going to use the easy formula. S equals r theta, right? I mean, I'll look at my formulas. That's the easiest one to use because I have r and I have theta, right? So S is equal to r, which is my 5.77, times my angle, which is my 1.5. And then I'm just going to use my calculator. Okay, so multiply that by 1.5 times by 1.5. About 8.66. So the arc length is about 8.66, and that's in terms of centimeters, okay? How am I doing? Am I doing okay? Okay, last but not least, apparent size. Now this one actually picture is drawn way too big, way too big, because really, think about it, if you're looking at something that far, Mars, it looks like a speck. Are you with me? Think about this, it looks like a speck. So it's so far away that technically the arc length and the diameter are almost the same, correct? So you could do a little bit of right triangle trig to get the diameter, or you could just say, wait a minute, S equals r theta, and S would be, in a sense, so the arc length is almost just about the diameter, right? So if we find the arc length, we find the diameter, okay? Does that make sense? Because really far away, they're so close. We'll just use arc length, okay? So here we go. We've got the apparent size of Jupiter is 0.01 degrees. Oh, degrees. So we got to use S equals degrees. Doggone that. Degrees is such a pain to do degrees. I got to use this one, okay? Degrees is a pain. That's radians are so much better. I'm going to convince you. The radians are better. Let's see, I got to go theta over 180 times pi r, okay? So that'll give me my arc length, okay? So here's my 0.1 degree. And if you're looking at something far away, that could be the apparent size. So S equals 0.01 degrees over 180 times pi. Now the radius has got to be this distance, which is really 8 times 10 to the 8th kilometers away, okay? Far away, that would be my radius. That's my radius. That's r equals that. So I'm going to put in my 8 times 10 to the 8th power, and I'm just going to use my calculator to get the answer. Clear. I'm going to go 0.01 divided by 180 times pi times 8 times 10 to the 8th power. And here's what we have. It's about 139,626 kilometers wide as far as its diameter. So last night, I probably could have gotten an apparent size of the moon, but the moon was actually really pretty close and pretty big compared to this. I would have been off by a lot because the moon was so big, right? I mean, there's definitely some curvature if it's that close. Okay, so that's what I have. Here's our homework for today. 265, 3 through 8, 11, 12, and the extra is 10, okay? All right.